Dear friends and colleagues, welcome to the ECOWEEK online meetup, a 48-hour challenge for in architecture and design. We're really excited to host the first of a series of online challenges organized by ECOWEEK. We are happy to see old friends joining us here today and would like to welcome new participants. After 15 years of activity in 17 countries, thanks to the coronavirus, we are going online for the first meeting with a new model of online interaction, which is allowing us to bring our members together in one single event. During these uncertain times, we are all experiencing a plethora of challenges. The pandemic has brought into light the weaknesses and problematics of the economic system. The alternative, which keeps a balance between nature and humans that our community has been fighting for, is more relevant than ever. We're looking forward to discussing in detail what the circular economy model can offer over the weekend. I would like to take this opportunity to thank our speakers, tutors, and collaboration expertise. A big thanks to all of you for your enthusiasm. The amount of registration we received was overwhelming and extremely encouraging to the extent that all of the workshops were fully booked within 3 days. A big thanks to our amazing team. Thank you for your hard work and friends and creative ideas. This event would not be possible. Last but not least, thanks to our partners who keep supporting us through the years. By the end of the day, and lessons by your tutors, each workshop group will hold their first online meeting by the Microsoft Teams platform. Please make sure you have downloaded and installed it on your computers as instructed by our IT support team. In case you have further queries, please contact your ECOWEEK team member who supports your workshop. It's an online experimental event, so please bear with us in case of any technical hiccups. Without further ado, please allow me to introduce you to Elias Messinas, Chairman and owner of ECOWEEK. Thank you very much, and we hope you will enjoy this 48-hour online challenge.
and thank you all for coming. Um, Welcome to the first ECOWEEK online event. As Despina said, this is our first online event. I would like, first of all, to thank Despina for the introduction. And I would like to, many of you know participant about 10 years ago in ECOWEEK. Then she became the organizer, and today she's one of our most important associates. So thank you, Despina. First of all, I would like to send our support to our friends who are still in still in confinement, coronavirus confinement, and our wishes for fell sick with the coronavirus. I would like to extend a big thank you to our speakers and workshop leaders and all the participants, all of you who came from near and far, from Greece, from Cyprus, from Israel, Turkey, Canada, Netherlands, Kosovo, Albania, Italy, UK, many more locations. A big thank you to our partners who have helped with the content and publicity for this event. Very special thank you to the organizing team, Despina, Margarita, Pavlos, Sofia, Eleni, and Vicky, who have been amazing in putting together this online event in a very short time. We are living in times of transition. Sorry. Ooh, what's going on? Okay. So we're living in times of transition from old models through a pandemic to new models, which are now trying to define. What are these new models? We don't know exactly yet. And why are we speaking about circular economy? And this is one of the reasons, because we'd like to think together with you what might be the new model for design and architecture. Because the way we design and we build our cities and the way we consume energy, they all extract a great deal of natural resources, and in return, they produce a lot of waste. We produce a lot of waste in the form of greenhouse gases, pollution of water, pollution of soil, pollution of air, contributes to changing the climate and the natural balance of the earth and causing extreme weather events. They also cause a lot of destruction of sensitive ecosystems and death to living organisms. But they're also a threat for our own air pollution, water pollution from plastics in our food chain as well. So our economy is really based on a model of extraction, production, consumption, and disposal that produce great amounts of waste, which our countries cannot handle. Our countries, our cities, they cannot handle it. So what do? They ship our waste abroad to other countries where lax regulation and corruption gets our waste in their backyard, destroying their land, their water, their soil, their culture, and they become a danger for their own health. So it's not only the issue of preparing for the next pandemic by keeping social distances. We must also adopt a circular model of design in order to eliminate waste and to protect the environment, to protect living, and most important, to protect our own health. So we have gathered this weekend to discuss how we, as professionals, can become part of the solution. We are here to learn and work together to design in a circular model so that we can reuse materials, we can reclaim resources, we can create new materials and methodologies, we can eliminate waste, and we can create better and more healing environment ecosystems around us. For example, here I'll show you some examples. We can use renewable energy. We can design in a bioclimatic design. So we can use the sun and the wind to heat and cool our buildings. We can reuse materials like the old blue jeans, and we can make them insulation, landscaping on the roof as insulation, but also to reduce air pollution and to collect the rainwater so it doesn't flood our infrastructure, the city infrastructure. We can heat and cool our buildings from the earth with geothermal energy and heat pumps. We can reuse building materials like doors, like in this project, use it as cladding. We can reuse building materials and we can use natural materials like earth and straw. And we can design buildings like earthships, like Michael Reynolds does, which are autonomous and disconnected from the grid and produce little or no waste. And demolition material, like Julie Bergman does, in very new, creative ways and incorporate it in our designs, like Julie does. We will see many more examples today from our speakers who will share their amazing work. We have a lot to discuss, to innovate, to design this weekend. ECOWEEK has developed a one-week design workshop model around the world, but this time, like also Despina mentioned, because of the coronavirus, we are trying a new format. This is an online meeting with online workshops, and we really look forward to develop together with you. Many participants have already been to ECOWEEK events, and we are really happy to see many of you joining back and being here. So, hello, we haven't seen you for a long time, and we're glad you're back. But there are also many of you who don't know ECOWEEK, so I would like to take a few minutes to explain what's ECOWEEK. First of all, ECOWEEK is an NGO with a passion to make our habits more sustainable. ECOWEEK's mission is to raise environmental awareness and to promote sustainability, both social and environmental. ECOWEEK was established in Greece in 2005, and since then, with activity in 17 countries, and our network has reached out to 56 countries. The ECOWEEK event is very much like a design studio. We start with our lectures in the first day or morning to introduce the theme, and then we split into workshops to design, to try new ideas. We work in small groups, and then we go out to get familiar with the site, to meet the neighbors, to meet the community, and to meet the stakeholders. We collect materials and tools from recycling, from storage, from any source that we can get, partners, sponsors, local businesses. Very often, they're very happy to get rid of these materials, and we are even happier to use them in our projects. So the waste of one becomes the building material of the other. And then we start building stuff. Materials we build in different scales. Depending on the site, the program, and the materials available, we challenge ourselves and the workshop in changing public space and in placemaking. We build in teams, our teams, but very often we're joined by the community, by school kids, by parents, grandparents, friends, teachers, everybody who's a stakeholder in the project. They join in and they help us in doing the work together. And it's really a lot of fun. Challenge, a different community that joins in, and of course a different result. This weekend, we will also recycle past projects and ideas, and we will rethink together how to make them more innovative and more circular and more sustainable. So, thank you very much for joining. Enjoy this weekend. Thank you very much.
Hello, this is Jan Jongert of CPU Studios. Very happy to be here today with all of you. I'm going to tell you a little bit about CPU Studios and tools we developed amongst Harvest Map that we use for the sustainable circular architecture that we're working on. So we're a team of 12 people based in Rotterdam. That's where our core is. Next to that, we have a studio in Beijing and one on site that is working on several projects, supply housing projects across Europe. And we're with 15 people all working on cases that I'll show you shortly. One of our inspirations is actually the enormous amounts of lose every year. This is a graph by an organization from Canada that shows yearly how much value is lost for steel, for aluminum, for food, since we throw away 1/3 of all our food is $1.2 trillion per year of losses. These are enormous amounts that we think can be used much more beneficial, and we try to create value in these losses. Even the renewable energy that we generate today actually has a big loss, which are the windmill blades that are changed every 10 to 15 years if they are working well. And then a graveyard of wind turbines, because the energy that we generate with it maybe might be renewable, but the materials that have created them aren't at all. So this is a graveyard in the US of the first thousands of windmill blades that are, and this is happening all across the globe. In the Netherlands, we also have them. We cut them, and then they end up in incineration plants. And even those incineration plants are not very happy because they harm the installations. For many years, SuperUse already exists since 1997. We have been incorporating these flows of materials into new architecture and design. And for instance, those wind turbine blades to us offer a great opportunity to create inspiring playgrounds. This was the playground in Rotterdam that we realized, where 5 of those wind turbines were adapted. Some holes were cut. We connected them to existing parts already in the playground and turned them into a very nice new playground. Into urban furniture like these slightly smaller windmill blades that actually give very functional seating in the city of Rotterdam. Or like this, wind shelters next to the sea. How wind turbines are designed these days is pretty different from how we did this 400 years ago. Here you see a typical historical example of Dutch windmills from 1600. Beautiful buildings, intelligent, I would say, than the ones that we are building these days, because they harvest energy locally. The energy that is harvested is used on site to either grind corn or to create new products, and even a shop is inside. So it is also a mix of functions in one building. And next to that, the building itself is built in such a way that it can easily be dismantled, and when it doesn't function on this site, it can be taken apart and moved to another site. Well, different from the windmills we're building these days. As CPU Studios, we're trying to get back to this kind of building, to actually learn from how those blades have been built, and design buildings made out of materials that we can find in our. And one of the first buildings that we designed was a villa in Enschede, which was made out of 60% of reclaimed materials. And for this house, it was also the first time that we used the term harvesting, where we started to harvest around in the neighborhood, either from construction sites or from local industry. And this harvesting resulted in a map like this with a section of a house, also indicating where what kind of materials we had been using, like a steel construction out of industry, insulation material from another building dismantled. And on the right side, you see a section of a detail and actually indicating where all these materials ended up. One of the materials we used for this house, which is also one of the parts that makes the expression of this house, are cable reels. They're wasted every 5 years after the use, carrying cables for infrastructure. We see this as a beautiful resource for all kind of wood constructions. The wheels might be not so usable, but the wood inside can actually supply a couple of square meters of facade. And again, what happens these days is that it ends up in furnaces, creating biomass energy, as we call it. But we actually think there's a much better opportunity to actually save the quality and the value of this material in a much better way. And on different types of ovens that actually don't incinerate it, but heat the material up to such a point that all the sugars get out and that the lifespan of this wood is extended by 5 to 8 times. So now our cable reels are turned into the wood being able to function as a facade. This is a picture of last year when we celebrated the 10 years anniversary of Villa Welplo in Enschede, which actually shows after 10 years how this material that you can see on the facade actually behave. I like is to get inspired by the size of these materials. So it's not just the material itself, but also the size actually defines the way how we design our facade. As you can see here in the horizontal lines that actually are the cuts between the different slats of wood that we found. Well, in this villa, we really worked this theme of superuse through to the smallest detail, up to lighting fixtures that are made out of umbrella beams. Another product that typically only lasts for 3 months, but in this case, we collected umbrella beams and turned them into lighting fixtures that already last 10 years, and the value obviously has been risen from maybe a €5 umbrella to an €80 lighting fixture. Funny thing is about that this way of building is not something new. We discovered by Vincent van Gogh, the famous painter, over 150 years ago, just before the Industrial Revolution started, where he actually painted an auction of the Church of Nuenen. This is a village where he was living at the time, and he, in the middle, an auctioneer selling the different parts of a church that has become redundant. And the local villagers actually bid for these materials to use them in their houses. So this is how before industrialization and also the digital technology development happened. And we tried to actually, because of course the scale of everything has been risen a lot since then, we really use current technology to actually reinvent older principles. And the harvest map is one of our first tools that we started developing. After 15 years of working in this way, we had over 200 sources in the Netherlands that actually gave us, that were able to supply us with materials. We thought, well, this is a very good way to actually turn this into a map ourselves, but we imagined many more architects would be able to use type of resources. So that's why we developed the harvest map, or oogstkaart in Dutch, which indicate sources that we found. When we built this, we made it in such a way that we could also use it for other countries. But so far, picking up a little bit in Italy, the Netherlands, and in Austria. Well, typical material is published on Harvest Map is, for instance, this steel material from steel industry. This is what remains after of cutting out different pieces. And we think, well, why transport this around the globe and turn it into new steel? Well, you can actually immediately use this material. In this case, we use it for a fence next to the villa in Enschede. And here, in London, where we turned it into two entrances for a public garden. And we, of course, used local steel for this. And we started looking at different suppliers of this material and also found larger scale suppliers. So, for instance, truck factories that have material in large quantities. We connected this flow of material to a commission for a waste collection center. So here, 1,500 square meters of this material has been applied for this project. And what's interesting is that this, for the first time, was a project that was commissioned on the base of the highest level of otherwise wasted materials to be turned into construction materials. So we won the bid, supplying them with, again, over 60% of these kind of materials. You can also, on larger scale, so for a housing corporation, we indicated how many resources they actually own in all of their housing. The 20,000 houses, which is half of their stock, actually supply for almost 12 towers, 25 meters high of materials. Here separated in wood, concrete, and brick, etc. So this gives a harvest in the city of the resources they actually own. And we actually scaled this, really knowing how many window frames they have, 16,000, how many toilet seats, how many doors, etc. So actually this gives the housing corporation an inventory of what they own, and if they start to restructure their housing, they can either use this or use this for new housing they're developing. And we supply them with a strategy to use Harvest Map and a construction supply market, a building hub that actually makes the connection between the supply and the demand, not just of their own housing, or of their of other suppliers within the city. The good thing is that because of this, we found a way how to actually change our the steps that we do during design process. I'm sorry, this is in Dutch, but what it shows is sketch design, and then after we have a sketch, we start harvesting the materials. With the harvested materials, we come to a preliminary design part, working on what do we actually buy from the Harvest Map. We create a dynamic definite design in order to allow other materials to be found during construction. And after we realize it, we count the environmental impact that we are able to realize. It's not always about construction materials. We also sometimes end up finding an industry like a beer brewer, having waste, spent grain, for instance, that can be used by a bakery in order to bake bread. So our scope is not on the construction industry and construction materials, but also we're looking at what kind of products are actually produced within the buildings. And this leads to a different philosophy, which is a little bit different from the circular economy. You probably have seen the image going from linear economy to recycling economy from the 70s to a circular economy that is now being promoted, which tries to prevent waste and create endless loops of materials. We think that sometimes materials will not have a function, but actually will be stored at some point, and new companies can actually create new products with it. So the blue economy, that's the one that we're actually trying to create many different types of values and also contribute to the natural environment instead of harming it. Well, the place where we actually collect this knowledge and that we initiated is a former swimming pool in Rotterdam. It's a tropical swimming pool that is now being redeveloped into a hub for companies all working on the blue economy. We designed like a master plan for the redevelopment, which will be executed over time and change every year, especially now with Corona. We have actually a high speed of redevelopment because there's no one that is bothered by the construction. This building, we actually also managed to have 90% of all the materials to be actually taken and harvested from the Netherlands and the region around Rotterdam. But by doing this, we calculate with the company also in Blue City the CO2 emissions that we are able to reduce, and we're able to actually reduce our impact with almost 70% compared to using new sustainable by actually just using what's already there. Next to this, I said we also have a company in China, 5 young architects on projects like us. The interesting thing is that the scale is much bigger, so we also have to think of different tools how to apply them in China. We came up with a Chinese harvest map some years ago that also has a collection of materials, but of course the amounts are 10,000 times higher than we encounter them in the Netherlands. Like for instance, this window frame company that wastes 200,000 euros of new materials every year because of wrong orders or the overproduction they have. There's around 3,000 of these companies within a 40-kilometer range of this companies. This is over €1 billion of loss of value every year that is not used because there's no harvest map. And that's, of course, what our harvest map is trying to overcome. And then we're also looking at larger scale industry. How can we not just use materials for construction, but also actually connect different industries to each other, a little bit like what we did with the bread and the beer brewer. We connect different industries that have waste with the resources of others. And in order to do this, we designed a tool called PulseApp. The different companies to see each other's waste and resources. And we're hoping that this actually helps open companies so that not just larger companies, but also smaller ones that identify a waste flow that doesn't get value, actually can create new value, new products, and new services with it in order to prevent the waste and increase labor and also have good value with it. Well, to conclude with, I will show a large project we're currently working on that actually integrates most of the ideas we have been collecting so far. This is a blue city like in Rotterdam, but then again 20 times bigger in China. This actually is an industrial zone where we collect the materials to start constructing of a water purification plant. We use resources from the water purification plant to create brick for the building, but also the program that is installed here that actually starts to interact with each other. So there's no large-scale factory, but the facade allows the different industries to exchange resources with each other. And in order to do this, we also have a harvest map to, of course, collect these materials, but also the company, it's like the resource valley, as it's called, has its own harvest map that shows which company has what kind of resources, so they can actually start to resources within their company. Well, to give you a little bit of overview of CPU Studios, our current development is that the harvest map in the Netherlands is now transferred to a large deconstruction company, so they will actually start to upscale the projects or the harvest map that we developed. They have a lot of resources buildings that are published on this, so for architects and construction companies, it will be much easier to find proper materials and start materials, so that the projects we've been doing can also be can also be started up by other architects and other constructors. We see actually quite a bit of traction on this happening, especially since the 2050 environmental goals that the government set. You now see housing corporations, construction companies, developers also wanting to move into more what is then called circular construction. So we are, apart from realizing our consulting these other projects, we sometimes make specific harvest maps for companies and write information and strategies to also develop their own projects. Next to that, also offspring is that we can also supply harvest map to other industries. So, for instance, green filmmaking is filmmakers in the Netherlands that wants to start to grow the greener film industry. So they adopted harvest map for their own industry and actually show where renewable energy can be found, or different props can be found, and where they can actually separate their waste. So the harvest map gets a different function on different spots for different industries too. Well, this and tools that we have been developing and the partners we're working with, I hope this gives you a good insight to join the workshop tomorrow about harvest map. This gives inspiration to design a small house. Having the waste that is everywhere around us in large quantities around us, and to turn them into an exciting aesthetic value. Good. Yeah, we're now working with different residential projects. So housing corporations start to adopt this. One of the problems is that sometimes it's more expensive because more labor is involved, and we're not trying to actually help the government move to a shift in taxes, so that labor will be taxed less and resources more, so it will become more profitable to build according this way. But already we're now working on 3 housing projects with over 50 houses. So this is not something that is impossible, even for new construction sites. All of it is possible. We made it in that way, the first version open source, so that everyone could supply the materials. But of course, we first put in resources that we found in the first 15 years of doing our projects. So also the knowledge that we find in our projects, we don't waste it, but we put it on a map so that others can access it. But by now, the new harvest map that's just launched, it has materials that are from larger deconstruction sites in the Netherlands. So it will be populated with many more products. No problem. Um, So what we do is we visit companies, we some municipalities to look at the industrial zone. We have statistical information that actually we can predict the data of resources and waste. So that's for each industry, we know more or less what is going in and out. But we also on the floor check these data with reality. They never match. And then we see what's really going in. So we are just very interested in how those processes work. And of course, every project we do gives us more information about these resources. So the question of me is how do we actually guarantee the quality of the materials? For a construction material, we have, for instance, kind of logical knowledge like wood. Yeah, if you use wood, either new or second hand, it doesn't really matter for the quality. We sometimes, like for instance, with the villa in Enschede, we upgrade it and then we get the guarantee from the company that actually the modification to the material. But also with steel, for instance, we take a little bit larger margin with the structural consultant that we hire. The calculations, and they for second-hand steel they take like 10% more structural quality that is needed in order to reach the structural integrity. So we list also for this, and sometimes it's just a matter of logical thinking, yeah, to use this. No, sorry, and now I missed the name, but Aliki, she asked whether every can be regenerated. No, this is not the case. Like some have been polluted with really harmful chemics. To give an example, for the villa in Enschede, we first thought to use railway sleepers, beams that carry the rail tracks. But we found out that they are actually chemical treatment that is not very harmful, but too harmful to be used in housing. So then we decided. Of course, we are longing for a future where these kind of hybrid chemical hybrids are not used. So that's why we also promote the bio development of materials, so that we can actually use every material that is on our track. So the second question about the fashion of different tools. I don't completely get the question. Sorry. Destina asks whether it's a main public or private suppliers of materials. This depends. Most are companies, so either demolishing, deconstruction companies, or the owners of the buildings. Sometimes it's municipal deconstruction that is taking place, so we have those. Mainly private, but the interesting thing is that also they are of course interested in a higher value for their materials. Sometimes they have to pay, or often they have to pay for deconstruction and the low processing of the waste. So if we can pay them a higher amount than they would otherwise get, they would also be interested. This is, for instance, the case with the steel that I showed. Normally, a waste company only pays 25 cents for a kilo of this material. We can pay them 50 cents per kilo for this material. So offer a cheaper material to the client of the building. So everyone has a benefit in this. It's just that no one knows the resources and the qualities and quantities, etc. of them. Thank you. Thank you for your support.
Buddy, ECOWEEK, thank you a lot for the invitation. Okay, I shall start again. So, good morning, everybody. My name is Panos Sakas. I'm the founding partner of the New Row. The New Row is a design and research studio that was founded in 2016 in Rotterdam and was founded by me and Fotinis Setaki. We both have an architectural background. We work with projects of smaller scale and not necessarily architectural. I would like to start first with a short video, just to make a better introduction about exactly what we're doing. So, as you might understood from the video, we are working with robotic 3D printing, like a large-scale 3D printing, and recycled plastic as a new raw material. And we focus all our research and all in the combination of this tool with this type of material. The reason why is that we believe that plastic is a valuable material to be wasted, the way it is wasted until now. And on the other hand, it is a material that we can actually include in a closed loop and for applications that are much more meaningful and useful than just a single-use plastic packaging or other types of products that are used for a very short period of time and then are instantly thrown away. When we started, it was easy to find. So plastic is a material that it's everywhere around us. Of course, the moment you start paying attention to it, you can see on the plastic packaging, you can identify the different codes and start understanding that it's one big family, but there are different types of materials. And here you can see some first experiments that we had done with our own plastic waste from our house and our office. Number one, a common plastic that is found in the plastic bottles that are everywhere. And number two is HDP, high density polyethylene, also very, very popular plastic, very common plastic. A lot of plastic packaging and products around us that are in color are made out of these poop bottles or cleaning products. And PP, polypropylene, number five, that is also a plastic very commonly used in many applications. There is some basic symbols from 1 to some about 6 basic types of plastics, and then number 7 for plastics that are like more mixed or let's say less popular. These are the types of plastic that we actually identify as very commonly used and as a problem, and we try to see how we can process them and turn this useful and more meaningful. When we start using 3D printing, and especially when we do it in a larger scale, the way we do it, we also create new possibilities in our design development and in our production. For instance, we can do custom-made projects. For instance, in this picture, you can see some benches for a new development project in Belgium that were made to communicate initially the project, and were resembling and were copying part of the architecture. So it was a furniture very specifically designed for a specific building, and at the same time it was a reason also for a local community or the new homeowners of the houses to collect their plastic waste or to do a cleanup in the river close by the canal. Use the plastic in order to build something for their public space. Another thing is that when we use 3D printing, we can actually integrate a lot of elements together. So in this furniture, as you can see left, it is a bench that has also integrated the foundation. And the reason why is that when you manage to create a product or a result that is a mono-material, then after the end of use of this product, its recycling, it's easier. Hence, using one material has some limitations, but on the other hand, you can manage not to use any adhesion, any glues, or any extra materials, lamination, that they can make a recycling of the object after the end of use very hard. So in that sense, it is designed more for a circular economy or for a circular process of dealing with the objects around us. The specific bench is one of 100 benches that have been placed around the south of Holland, around where bikers can actually make a stop and have a break, enjoying the view. In the same way, you can customize. So the same way many of you might be able to do small, let's say, models in the 3D printing, in the desktop 3D printers, you can larger scale. You can create hybrids like this furniture that was made for an exhibition and for an expo. That was a combination of a bench and of a side table. And at the end of the expo, this material could be shredded again, could be broke down and be used for something else. If not, the whole project or the whole object could be reused again. So in my presentation, I would like you to explain the principles and the way we work in the Euro, basically through two main projects that we have last 2 years. The first project is Print Your City. That was a project that we have started developing since 2016. And we actually managed to apply for the first time 2 years ago in the city of Thessaloniki. We launched in customer Coca-Cola. It was a project where we went to the second biggest city of Greece, Thessaloniki, and we tried to apply a quite simple idea to think, but harder to implement. What if we could actually take the plastic waste of the city and turn them into that the citizens themselves could decide how they are and placed around the city. The initial idea was to make furniture for the public space. And the reason to do that thing is that it's a place where people spend a lot of time, and it's a space where you can actually waste around you. For this purpose, in the center of Thessaloniki, there was an experience center. We created an experience center where we brought one robotic facility, and also we created an educational program where people and everybody who would be interested could learn more about plastic, more about the correct use of plastic, more about the data of plastic, and at the end be able to see an application such as Print Your City. This space, unfortunately, is no longer existing. It was for 1 year, last year in Thessaloniki. At the same time, parallel to the awareness, so people could come and really learn about more about how we can use plastic and what we can do about that, we had launched a website from this project where people could actually harvest the possibilities of 3D printing. They could decide what type of size or shape their furniture would be. So let's say straight line. They could also make a decision about what functions this furniture might have. Would it have like a bike, would be bike parking, have some plants, be a dining place, or like have facilities for your pet to have their water or to, and so on. So this website was launched. People actually logged in, and we had at the end around 2,000 unique designs, and also the color. And at the end, you could see how a concept of how your furniture would be, and most importantly, also how much plastic would be needed in order to do that thing. So combine awareness also together with the actual product. So yes, as you see, this is the video. And of course, these 3D models in the website, it was just a representation of the final result. The final result was this furniture that they combined, the people, the participation of the people, let's say, led us to choose at the end. And at the end of this effort, 10 of them were placed in a central square in the city of Thessaloniki. Also, in parallel to that, we launched also a pop-up installation in the city in order for people, before starting the whole process, people to understand what they could expect, to start seeing the furniture, to start asking about what the material is or what it is, and also start imagining how they could actually shape their own public space. The furniture that we made were specifically combined with big plants. So we didn't just want to have like only like a sitting element. We want to add more green into the city. There were like actually large pots for small trees that they could create some shade, could add green. The same side could create a sitting element for the people. And they were heavy, but they were also movable. So we actually placed them temporarily in the seafront of the city of Thessaloniki and for 1 month, and then we brought them back to the experience center, and at the end we did for more permanent installation in the square. You can see that apart from the awareness that nowadays more and more information problems that are caused and also the opportunities, people can learn about it in the internet or in many other sources. We really want to demonstrate also to the people like the possibilities of how you can make use of this material into do something. So the Zero Waste Lab was an open space, so youngsters, but also older people could come and really see how the plastic was shaped into the furniture that they had designed. At the end, a big success of this project was that we achieved to actually make everything in kilometers. So we sourced the plastic from the city. The center of the sorting of the plastic was in the limits of the city. Then the recycler of the plastic was again in the limits of the city, and then in the center of the city, a small factory where the actual products were produced and then placed again inside the city where the citizens defined and chose them to be. So in that sense, it was very interesting to do some things very locally when you really make use of a waste stream, of a waste source that is so popular and so dominant, together with some innovation, some new technologies. The second project I would like to is called Second Nature, and it's a project that started again 3 years ago with a short film about its idea. So I will show you first the trailer of the film, and then I can tell you more about it.
Σκεφτόμουν ότι η μορφή αυτή που θέλουμε να κάνουμε της πίνας να θυμίζει μεν πίνα, αλλά να θυμίζει ταυτόχρονα και κάπως την κίνηση από τα δίχτυα όταν τα βγάζεις από τη θάλασσα. Τι είναι αυτό?
Ένας άλλος ιστορίας. So Second Nature was a film that we did together with the cinematographer Daphne Maggiaraki and with the support of the Katerina Laskaridis Foundation. That was actually focusing on a different type of waste, of plastic waste, that it's not visible. Sorry, a second. Another type of waste that it's not visible, plastic waste that it's not visible, the fishing gear and the old fishing nets that are actually being stuck or thrown away in the bottom of our sea. They are made out of plastic, and actually they are one of the deadliest trashes in our ocean. Unfortunately, they are invisible. We cannot see them, but they are actually traps where animals and like small mammals, small fishes are being trapped and killed with no reason at all. The idea behind this, we said, okay, let's focus on this waste stream. Let's initiatives and organizations that actually do something about it, because there are many that actually do, and let's see how we can make use of it, and then create some products and some objects that have storytelling, so people can learn more about it and maybe get more aware and more acting about it. So here in the image, we started with small prototypes, like statement pieces, we might say. They were printed in a smaller desktop printer from fishing nets that we actually collected from the coast. We cleaned, we shredded, we processed them into 3D printing. Maybe here it's a good point. I think I missed that our process is that after identifying the type of plastic, in order to be able to process it, we have to clean it, and we have to break it into small pieces, like a hard sand, and then we heat it again. So we remelt it, and we bring it in a state that it's a bit soft. And with a 3D printer or with a robotic arm, we can actually shape it into the shape that we want them to have. Of course, we started with a small scale, but then we went also to a bigger scale. And our action tool many times creates limits to us, but sometimes we are also trying to overcome them with different techniques and different ways of thinking through design, but also through craftsmanship. So here it's a table that was made with, it was all printed flat, but then was created with the thermal bending. But at the same time, and the most important of all, we actually inspired the birth of a new company called the Blue Cycle, that right now they have a facility in Piraeus in Greece, where they collect the plastic marine waste from the shipping industry and from the fishing industry, and they turn it into raw material for the industry to use, or the designers to use. We have set up a small lab in their facilities in order to be able to experiment and see how we can work with that and what kind of products also we can do. The first products and the first series of products were seating elements, were furniture that were targeted for the hospitality sector. New project. It started 5 months ago, and this furniture were supposed to be launched during that period. So you can understand that with the crisis that the pandemic created, hospitality sector right now, unfortunately, is quite. But nevertheless, it's a place where storytelling about a more sustainable. Nevertheless, for us, the storytelling of our products is a very important. Is the way where you can actually raise awareness from the public and the users about really issues like plastic waste, and better understand how to deal with it, and how to change also behaviors. That's a very important thing. So these are the first prototypes that we created, and as I said, after all, 3D printing gives us freedom to really experiment with shapes, and the plastic waste is actually a material that gives us a lot of quantity to test, but at the same time, big challenge to actually turn it into something beautiful and useful. Your attention. That was my presentation.
Okay, Panos, that was very inspiring. There are some questions. First, my Juliana says that it's all.
Okay, so the first question was about whether the objects are made from one type of material or a mix of different materials. Ideally, we want to have objects made out of one material. Sometimes we mix materials because they have very similar properties. But of course, then when the moment we mix them, the plastic, it's good to know, it's good to have the identity, because the furniture that we are creating here, they're not furniture that, let's say, at the end of the use, you just throw them in your recycling system and they can be recycled. Furniture that can be recycled again from us, because they have a recipe where we can actually break them down and actually use them again for 3D printing. So there are some types of plastic that you never mix, and the reason why you don't mix is because they have different melting points. So one plastic melts, the other doesn't, then it doesn't work. And some other plastics, they have similar melting points, but they don't stick to each other. So it's a bit of a chemistry. Of course, we're not chemists, but we are practitioners. So through practice and with talking with experts and suppliers, we learn how to better. In principle, it's good to have like one type of plastic each time and not mix them together. That's a very good question about how car. There are different types of plastics. It's a different quality of plastics when you create a cup where you're going to put it in your mouth, or like when you create something that you're going to put on your table, and a different type made to be used for cups that you can put them in your mouth. At least this project that I have shown you right now. Of course, this depends on the supplier. When we, for instance, in places where we do small campaigns and people collect their plastic, we wash them with a partner. You wash your clothes, but we don't sterilize them so that we can create products that you can be placed on our mouth or on our table. Um, All right. Sorry for that. It was a problem with the connection. Are there any more questions, or should I just presentation? Uh, as I said, most of the plastics are recyclable. The plastics that are not recyclable, ones that are mixed together or laminated, or like that they are thermosets, so they're not thermopolymers. Every plastic has their own properties, so not every plastic is, let's say, very suitable for 3D printing. And you can actually see that thing if you're trying to find plastic for filament for your 3D printer. You will not see many different types, similar types with the plastic waste that are out there in the recycling, let's say, stream. What we are using, because it's a good, it's a different type, it's a good type of plastic for the final application. But the problem is that the packaging and the recycling, they are not made to be used afterwards for 3D printing. So they are made with a different type of technique, and then they as good. So the layers don't stick together. That's why sometimes you have to use additives, and there is a lot of research for many materials. So there is not a clear answer whether there are more than one type of plastic that can be recycled. I think every year more research takes place on that thing. And maybe in the future, packaging will be also made in a better way so that they can be easily recycled, nothing but for other applications also. Yes, no specific way of seeing how many times you can recycle a plastic. It depends on where it is. For instance, if you put a plastic chair in the middle of the desert and you put a plastic chair in the Arctic, and then you put them again, the material it doesn't have the same let's say rhythm of deterioration. In the desert, in the environments where there is more light, there is definitely the material is degrading more. Also, it depends on the thickness. Something that has a really small thickness of plastic, then it can really break very easily. If it has a bigger, then the top layer degrades, but the middle layer, let's say, it's being, let's say, better protected. So you can see this degradation sometimes, but many times in a really small, like thin prints, you can also see it in the structural properties. All right, thanks a lot. Have fun.
who would be joining me, Khushbu, for this presentation. All right, so we stand for more, which is.
Does it work?
All right. Welcome everyone for the talk of the MORE team. Firstly, we'd like to thank the organizers ECOWEEK for giving us the opportunity to share our experience. We are MORE, which represented TU Delft at the Solar Decathlon Competition 2019. I have Anna and Francesco, along with me, Khushbu, who would be taking you through our journey. So what is MORE? For modular office renovation. How this all started, it started with a small team that came together in the afternoon of students who were ambitious enough to come up with the first proposal for the Solar Decathlon competition. This started back in September 2017. What is the Solar Decathlon competition? So it's a competition that allows students from all across the globe who have the ambition to think beyond the box and have a sustainable vision for a future. So we all different teams came together with the same concept of renovation, and we tried coming up with different strategies for it. And what you see here is the solar village at Sentenza in 2019 in the summer. As the name suggests, Decathlon, that means 10 different contests. So we were evaluated for 2 years across these 10 different contests, which included architecture, engineering, construction, energy efficiency, communication, social awareness, neighborhood integration and impact, innovation and viability, circularity. And 3 of them were actually recorded and met site during the competition, which included comfort condition, house functioning, energy balance. The MORE team of members from different faculties across the TU Delft. So 8 different departments were actually involved in this process. It comprised of a team of 52 students, which came together from 20 different countries representing the Netherlands at this competition. We had people who were mechanical, students who were mechanical engineers, civil engineers, electrical engineers, architects, designers, and we had a lot of outside who helped us, along with a lot of faculty members and all our different partners. So this MORE team not only comprises of us, but also everyone involved. This was our team standing very successfully celebrating our second position in the competition in front of us in Hungary. It was definitely an overwhelming moment for all of us in the team, as you can see. Why did we choose to do this? So as construction and as we know, the construction sector contributes to 30% of the CO2 emissions, 40% of the total energy consumption in the world. And however much as we know that 50% of the construction waste ends up in landfills. So we tried to address that at a global level, and at a Dutch level, we have an issue that offices below energy label C would be shut down in 2023. This accounts for 2/3 of the total office stock in the Netherlands. On the other hand, for housing, we need 1 million new homes by. So the MORE team tried to address these 2 issues through our journey within the MORE team. We tried to transform these inefficient office buildings into net positive mixed-use functions, that is giving back to the environment more than what we consume in terms of energy, water, air, biomass, and material. For this, we chose a case study of the iconic Marconi Towers in the city of Rotterdam. These towers were designed by SOM Architect, and exactly the 3 towers have been replicated 6 times across the globe. Office building from the 70s and 80s with a central core and which was net positive, circular in its approach. We tried to create a lifestyle the inhabitants within the building. Shared economy was what we tried incorporating, and also giving a better lifestyle, a better future design. So regarding the facade concept,
our main aim was to take full advantage of the large facade area, because in high rises we do roof area, but we have a large facade used for energy production. But at the same time, we wanted to preserve the iconic river, which is a strong landmark in the area. So we chose to replace the existing cladding with new technology of colored panels that allow us to preserve the same image, but at the same time to integrate strong elements that display the net positivity, such as the vertical black stripes that you see, that are the solar chimneys, which I'm going to explain later. While at the bottom floors, we proposed natural facade panels to purify and cool down the air at the pedestrian level. So as Kuzbo said, regarding the program, week's function program for the whole complex, with an open to the neighborhood ground floor that hosts commercial, educational, but also leisure activities for the whole neighborhood, while the main part of the town combines residential and flexible co-working spaces together with various common areas and green the rooftop. Our main target group was the young professionals who are very much attracted to this particular, and we wanted our design to be affordable for them. So one of the main ways to achieve that was indeed to integrate these various spaces within the building. As an example, not every apartment needs to have its own laundry machine, for example. We try to integrate all these shared facilities into the core of the building and come up with even more common areas, such as kitchens or food productions, where the residents can interact and share resources. And regarding the dwellings, we wanted to provide a variety of spaces. So we came up with small units to large co-housing apartments that can be combined with winter garden spaces, but also with working units. Again, one of the main aims was for a design to be flexible and adaptable to the future needs of the residents, but also to the market needs. We wanted to be able to expand apartments or combine them, but also to allow easy transformation from residential to office use and vice versa. Therefore, we came up with a fully modular concept. We designed 4 main modules: the kitchen bathroom module, the bedroom workstation module, facade module, and the wall modules. So these served as the renovation tools and were all prefabricated to save time, cost during the transformation process. And as you can imagine, we were not able to build the whole tower during the competition. So what did we actually build? Was this. And this is from the Solar Village in Hungary. So it was a cutout from tower, a southwest corner with a 50 square meter apartment for 2 people and a winter garden. So the layout of the apartment really suits the lifestyle of young professionals who tend to work from home more and more. So we wanted our space to be flexible and adaptable. So as we can see in this diagram, during the day, we have the sliding walls open, bed modules folded up into desks. So the whole space acts as a unified working area, while during the night, the walls close and create 2 separate private bedrooms. And when weather conditions allow, the whole living space can be expanded winter garden. Here we look at the floor plan of the build prototype and how we actually integrate net positives that Kuzbo mentioned before into the design. And again, to give you a better understanding of the space, at the bottom we have the entrance to the build prototype, to a platform deck we made to represent the common areas of the building, while the actual apartment happens from the winter garden in this zone. And then we have the main living space with a kitchen module in the center and the 2 rooms. So our main approach to achieve net positivity was to first try to reduce the demand as much as possible through passive design strategies, then try to any available resources, and finally apply any active systems sustainably. So starting from the energy, the goal was to produce more energy than what we consumed, with an ultimate vision to either store it or distribute it to other buildings. And we started again by minimizing the demand. So here we're looking at a view of the winter garden, and as left the whole concrete structure exposed so as to take advantage of the thermal mass. But we also made use of the winter buffer zone. We placed there a large quantity of phase-changing materials that allowed us to preheat or pre-cool the air before entering the apartment. So various passive strategies were combined with energy-efficient systems and a high-performance envelope. So again, we look here at an image of the facade where, as I mentioned, we have integrated solar production and these solar chimneys. So what these do is basically they combine PVT collector system for heating up the and again solar panels for energy production. Regarding water, our first priority operate on the different flows. Therefore, we divide it into freshwater stream, grey water, black water, and with a strategy for all of these streams. In the build prototype, we implemented a helophyte water filter system. The system does is it collects the rainwater and the grey water, which is then filtered through the roots of plants and distributed for other purposes, watering the plants or flushing the toilets. Moreover, we made use of water-saving equipment such as vacuum misting shower devices that helped us save up to 40% of water. Regarding biomass, our main was to explore food production possibilities within buildings. Therefore, we mapped down the different biomass and we were able to install and implement an aquaponics system. So this is a fully circular system integrating edible plants. And what happened is that the fish excrement are used as nutrition for the plants. And in return, the plants water from the fish tank. So in the end, both plants and fish can be consumed. Air positivity, our main goal was, of course, to purify the air pollutants. And here we see again a view of the winter garden. We placed a living green wall with air purifying plants that would filter the air before entering the apartment. And besides, we also came up with different strategies regarding environmentally friendly materials for the interior or natural strategies. And finally, regarding the materials, the main aim was to minimize the materials used and use materials with as low environmental impact as possible wherever we could. And finally, come up with alternative business models regarding the life cycle of materials and products. Here we see a view from the living space towards one of the bedrooms, and we can see some interesting materials that we used, such as the floor tiles that were almost 100% natural and fully demountable. Or in this view, looking towards the winter garden, we see, that again, like we said before, the concrete stacks closed, but we also made use of reused items, such as the climate ceilings that were previously installed in another office building, or second-hand furniture that we bought from local stores. And here we take a look at the module of the kitchen. So there we experimented with some fully bio-based materials, such as the canapalithos, it's the black material used in the kitchen. And of course, as Francesco is going to explain with more detail later, all the elements were designed for disassembly. Same for the interior modules that were made using CNC milling and with dry connection. So yeah, I'm going to give the word back to Kuzbo.
Yes, regarding the circular business model, we accounted for different concepts such as adaptability, flexibility, shared facilities, mixed function. This was all so that our user targets have affordable housing. In the Netherlands, a shared room within a house comes in the city of Rotterdam comes for around euros a month, which is quite high. So that's the reason if you see the rent level per month per person, we try to keep it below that level so it's affordable for newly graduates and starters within the city of Rotterdam. We promote and we really hope that people have a more shared culture. That's the reason the more you share, the lower your cost of living is. So that was our circular business. Also had a lot of strategies for how the materials will be readapted with after its current use and how everybody can make this system. So it was all planned for and it happened to be feasible. I would now hand over the mic to Francesco so that he can give an overview about the construction process.
Yeah. Okay, thank you very much. So let's give a look at what we and how we build it and add it to the final prototype. Because of the competition that was held in Hungary, we had to build a type first in the Netherlands so that we could learn how to actually build something, because we are all students and we don't know how to build it. Then we had to disassemble it, take it apart, ship it to Hungary, build it for the competition, disassemble it once again, and bring it back to the net staying now. So to do that, I will just take you through a bit of the planning that we used and what integrated for us, and then I will show you examples of our design for disassembly on site. So as you can imagine, 2 years takes a bit of looking ahead and how you're going to perform this project. So we had a timeline that we as much as possible, where we first went from design all the way down to assembly. If this was the first rough idea, we ended up on site with this kind of project planning with more than 300 tasks that will say everything that we had to do and how much time we had in order to build it on time during the competition. And another level that we had to look at was how to organize the site, because we are supposed to build the prototype within an area of 30 by 20 meters. So we had to make sure that everything that we were building will be able to arrive on site, positioned on site while we were working on other parts of the building. Transporting an entire building across Europe, planning also from the transport side, and we tried to model the volumes that we needed to transport and put them into our trailers using 8 trucks, and that were not loaded, as you can really see them here. Were a bit more messy, but we ended up using the right amount. I would back once again. Of course, construction elements are not always made for disassembly, so some we were not able to recover because, of course, it didn't break during transport handling, but we ended up reusing the majority of it. And here you can see one of the last phases of the flooring system, and with interior wall here we were about to place the floor heating and cooling system. And of course we went all the way with this concept of the ease of assembly from, once again, the concrete structure all the way down to the interior elements. And here you can see the bathroom modules being built that was all assembled through something like this. It's just a normal alloy key. Something very, very quick and easy to take apart and disassemble again. So what we learned out of it, we learned that it's possible to design for disassembly. It takes
with the initiative that recycles garbage from the oceans. So we have that plan to make use of this waste found in oceans. Also from the canals, it's pretty common that you can find many items, bicycles and many waste items in there. And our plan was to come up furniture ideas and make use of that. But in the end, we only did it to a certain degree. We didn't have the time further on that. but it was within our plans, let's say. Other questions? Okay. Okay,
No
it's fine.
problem.
Thank you very much.
Yeah.
Enjoy the second part of the lectures.
And hope all of y'all stay safe at home. Thank you.
Thank you. Bye.
Bye.
So, hello. Thank you for coming in to listen to the presentation and to attend ECOWEEK. My name is Kostas Giannakopoulos. I work in the National Center for Scientific Research, Demokritos, in Athens, in Greece. And I will be talking to you about advanced materials, what we mean with this term, how we can make the world be sustainable with the use of such technologies. So start by talking about what we mean about materials, give you a few examples, what are advanced materials. Then we'll go on and say a few things about our next work in self-cleaning surfaces, making smart nose, and how these are related to the concept of circular economy. Things about some videos and a game that we made in order to make people realize the importance of this in the technological field. So, Bertrand Russell was a philosopher of the 20th century, and his definition for the word work is that it's altering the position of matter or near the Earth's surface relatively to other such matter, and also the way you make people do this by giving an order. So, humanity, after having changed almost every relative position of matter on Earth, tried to go deeper, and that is the higher magnification, and change things in the nanoscale. So inside materials, tune the properties of by changing the position of, let's say, one phase, crystalline phase to the other, or even the position of atoms within the matter. And now we have reached this level. What you see here on the left is a transmission photograph. This is about 1 million times. What you see here is the heart of a microelectronics chip. This is what makes us communicate today. The lines that you see here and the dots are actually silicon atoms. So the distance between these dots is about 3 angstrom. 1 angstrom is 0.1 billionth of a meter. So what you see here is an insulator. It's what keeps the current here and away from this part. This is an insulating film. It's an oxide that is the critical part of this device. What you see here is an array of dots. These are very small magnets. They have also diameters in the order of a few tenths of billions of meters. Why am I showing this? That is that now technology is reaching to such levels, not only making these things, but also seeing them, and also understanding how they can be used. And this is giving us a lot of new possibilities that we didn't have before. We may wanted to do a lot of things, but we didn't know how to do it. So now in the last 20, 30, 40 years, and maybe more, technology is evolving so fast that we can manipulate matter in the nanoscale, okay, in the billionth meter. Okay, you maybe already know the importance of materials in the history of civilization. Actually, what we call the first civilizations is when, this is almost by definition, I think it's a definition, it's when people made the first artificial materials that were ceramics. Moving out of using simply wood and stone and all this natural material, they found ways from clay to make storage for the food, for their water, to be able to carry things and food in long distances. So ceramics were like a revolution on their time. The same thing was metals. When they discovered metals, they started to do even more things. Civilization started to develop much faster. So in the last 200 years, we saw steel made the modern cities as we know them. We have skyscrapers, tall buildings. We can live next to each other, and we can have good quality of life. And of course, the last 40 years or so, semiconductors changed the way we live again. This enabled us all this information technology. So semiconductors, such as silicon, allows me today to have a digital connection with you, which is much faster, quicker, consuming less energy, and this is why it goes everywhere. Compared to the previous methods that we have. Now we live in the semiconductor era, and what we see around us is the result of many thousands of people that work to make these semiconductors very reliable, go to functions. And for example, the LEDs with which your screen is now illuminated are this kind of materials. I won't say so much about this. It's obvious that you have great effect in the world because of that, of these materials, but materials that are now changing our world. For example, we have new types of drugs where these nanoparticles, these nanomaterials that we use, can target cancer very specifically, release drugs in very specific spots, and there is a whole revolution that we're going to see. Now, there are many options about that. Of course, catalysts have made our transport much cleaner and our cities. Imagine what Athens would be like without catalysts in the cars that have been introduced the last 30 years. And of course, we're using filters for water, for cleaning the air, and now they are very relevant with the coronavirus crisis, these advanced filters that they make. So to say a few examples about another very interesting thing that's happening, and it's been there for many decades now, and it's like nobody really recognizes its importance. Okay, this is a bearing. It's roulement, as we call in French. This is what makes your wheel rotate with a minimum friction. So here you have these little balls and very tough material. This thing can turn thousands of times per minute. And it doesn't get so much warm, it doesn't get destroyed. This is because people have made hard coatings. So you have a ball which has some kind of steel, and then on it you have a hard coating. This is an electron microscopy image, and that shows how it is in a cross section, how you look at it on the side. So this could be your substrate, your metallic ball, and this is the hard coating on the surface that protects the ball from being worn out by use. So these kind of materials have made transport really cheap. They have made various machines work in your house because there are many things that need to rotate, motors for air condition or in your fridge. And they have also made a very important contribution into what we call a sustainable world. It may not be understood by all, but it's hidden somewhere in there, and there are thousands of people that have worked in this as well. So now we'll move on to some, let's say, more obvious stuff that we're working on. We're working on sensors for reducing the waste of food in large food reserves. We are working on making surfaces that are being cleaned easily or by themselves, and large energy production facilities work more efficiently and needing less consumption. And of course, in Democratos, not me, are working in stuff like glass, which is also working as a photo. So this is an application of such a glass in Lausanne, in the convention center of Lausanne, the conference center. This you can see in the film of the person who made this film, who made this glass and the film which is on it. You can see in our own film that I will tell you at the end of my presentation. So there are many applications where self-cleaning surfaces are very important for circular economy. One is this energy production. All these things are mirrors reflecting radiation on this tower. There you can have very cheap way of increasing temperature for various, let's say, energy hungry applications. The problem is that these things get dirty and you have to clean them. And if you are in Cyprus, as if in this case, or even in the Arab world and near the sea, you have only salt water, you might have a lot of dust. Clean water will be very difficult to find, might be actually very, very expensive. So we have a project to reduce this water consumption by using hydrophobic surfaces or super hydrophilic surfaces. That we have any surface and we can coat it with a very, very thin coating of a few nanometers, a few billionths of a meter, and turn them to repel water so that every droplet that goes on them, this is one of them for example, doesn't stay. It can easily flow out. It will not stick to the surface. As it flows out, it takes it with it any dust that has remained on the surface. That way we can make very thin films that we make these water droplets attach everywhere to the surface. By doing that, and with the help of the photocritic material that we have put, they dissolve any piece of dirt remained on the glass. And then with adding a bit of more water, you can just wash away even dirt that has been stuck on the surface. Another project is the creation of sensors for reducing food waste. So these are huge containers, what we call silo in Greek, for storing corn, seeds. By the way, it is circular economy to have massive production of products and food. Imagine how much waste of energy and resources we would have if we producing food in smaller quantities or even worse by himself. We know that about 70% of products are lost in the post-harvest contamination problems that they have. This means that fungi is growing inside these large containers, and the earlier you can understand their presence, the earlier you can take out the corn and do the right things to save it from getting infected from the fungi. This may need a matter of, let's say, hours to realize. We know that fungi produces volatile organic compounds, as we call them. These are stuff like alcohol, actually. So we're making sensors, very small ones, that fit in larger devices that are connectlessly with a central system that can analyze all the data centrally many times, and this way we try to reduce the contamination by fungi. This is an example of a device like that. I hope you can see it. These are like some electrodes actually. We measure between nanoparticles as this. Now we go again to the nanoscale, and these are covered by a polymeric film, which is to these volatile organic compounds such as alcohol, acetone, or even complex ones that I'm telling you, it's that actually the smell of the fungi. So this will change the resistance of the film. This smell will change the resistance of the change in resistance will give you an electrical signal, and the signal is then being developed with the help of artificial intelligence methods. It's being processed to a central computer to and information about what's happening. I'm not going to say many more things about that. I will have a few minutes just to say that many materials are made by chemistry, vents and pipes and what you need to manipulate liquids. In our case, many cases, large part of the production of new materials comes from machines like that. These are high vacuum systems. What you see here is an laboratory equipment. If you see, you have a lot of pipes, and here is under vacuum. And it's so complex because besides the deposition that you have a lot of monitoring systems to actually see what you're actually doing in the nanoscale. And you need even more than that, whole buildings with microscopes, optical measurement systems, hardness, everything that you can imagine in terms to characterize what you have tried to do on a surface. For example, the nanoparticles I showed you before, the surfaces for the insulators in the chips and so on. This is an industrial system. It looks less complicated because here we know what we're doing and we're just repeating a process. But this is much bigger. It's having the size almost of a room, because there we can go to mass production and create layers, coatings that in a very large area. In these things you can have a very, let's say, repeatable results in the nanometer scale in a substrate which can be 1 meter. Okay, the diameter of 1 meter or half a meter. Okay, just a few things how you can find more things about this technology and how it enables a sustainable world. It's all about this. It's about biomimicry. It's about new concepts that complicate of living materials. There are many things in that. It's this website, Materials Future EU, that you can see here. There is also a game there where the player plays the role of the scientist in a world that is just starting its civilization. And this guy is trying to find the recipes, the processes to make new materials. As he goes to develop this material, he has to find the tools, the processes, to buy them and then to sell them to the village where he lives in. The society evolves, and it evolves from ancient times, prehistoric times, to the far future, where if you have found the right formulas, recipes, you can have a sustainable world. So this is what I want to tell you. Thank you very much. Just to say that you can contact me in this email address. In this presentation, there was also from Nafsika Muti, who will also be a tutor in the workshop that will take place in this weekend. So thank you very much. So I can carry on talking. So do people see me and the presentation as well? I'm not sure about this. Thank you very much. Bye bye. Thank you.
Hello, everyone. It's so nice to be here, and thank you all for joining me on this short presentation. So my name is Lisanne Dirks, and I work for Superuse. And some of you might have to the talk of my colleague Jan Jongert, one of the founders of Superuse Studios. We are an architecture and research studio from the Netherlands, based in Rotterdam. And I am trained as a product designer, actually, and I work for Superuse as a designer, a researcher, and also as a trainer and facilitator. And in this context, I will give a workshop as well tomorrow. And I will tell you about one of our tools. It's called the value system. And just for the ones who did not see the presentation, I will give a short introduction on what is the work of Superuse, and that will also be the philosophy behind the value system game, so you will understand a little where this this tool came from. So the first project that I want to show you is okay. So I'm not online anymore? Oh, no, don't worry. Shall I exit and start again, or? with the people that have subscribed to the value system game workshop that I will be hosting tomorrow. So the next part of my talk, so the next 5 to 10 minutes will be about how does the value system work in Miro, in the program Miro. So to start with, we have different cards with different roles, let's say. So we have input cards on the left, which represent virgin resources, let's say or electricity. There's immaterial resources, and they go into a process, which are the middle cards: cutting, harvesting, baking, can also be selling something. And then transport is also a process, but it's quite distinctive and always used, so that's why we put it as a separate one. And then after a material has entered, I have to close this. After a material is entered, it goes all system again. And as a product or service, as an end-of-life waste, or as waste as a resource. And we have some value tokens which can be placed in the system where most value is added or where value is lost. So the next slide you can see our worksheet. I will go out of present mode for a second so I can show you a bit more dynamic how that works. So for example, you take a virgin resource card. This is our playboard for tomorrow as well. And you can write down something like wood. And then you can take a process card. You take it and then you can connect them with an arrow to show that wood is going into a mill, for example. And then you get a number of processes that you can, which I will show you later. But this is roughly how you play around with different cards on the Miro workboard. There's different in the game. There's actually 3 different steps, and I will walk through them one by one. See the first And we're back. So I'm not sure what I fell out, so I will just say that just a quick recap. Step one, you put down of a company or the process of a project with all the flows that go in and out of it. And the whole and step two, you identify the value, the most important value. Where is the most important value created? It's not only monetary value, it's also ecological value or social value. And you show where most is getting lost, which is often where there's a lot of waste created or where there's a lot of inefficiencies. And in the third step, that's where you start innovate. That's where you start to look for circular opportunities. So what we often do is we look at, hey, how can we all of the end-of-life waste cards with a blue card, which stands for waste as a resource. And for example, can we compost the agricultural waste to use it as a fertilizer, or can we use the coffee grounds? And this is project that is all over the world quite famously nowadays. Can we use a coffee ground to grow mushrooms on it and use these mushrooms again for cooking of all sorts? And this is when a end-of-life waste flow becomes a new valuable resource. With the value, this is actually the goal of the value system game, to create a new system with maybe multiple value flows that come out of one project or one company, and where waste is minimized, and therefore where ecological benefits are created and also social benefits. So that's step. Now, during the game, if you need a bit of inspiration, there's always question cards, and these are the cards where you can example how you can zoom into one and you can say, how could you collaborate with a local partner to create more value? Or you could tell, is there ways to eliminate steps in the process to become more sustainable, or you could ask, sorry, I'm going to zoom in again. Where might you be losing heat, energy, or heat? Can use more optimally for something else. So the question cards are more like when you get a bit stuck. But I will also, as a game host, help you within the game asking questions. So for tomorrow's workshop, we will be working a fictional family house, and we will not only look at the building process, but we will also use phase, and we will make flow diagrams as I showed you before, and showing which resources go in and out of the building, and we will optimize these flows and design and the design of the building using the super use approach. And this is it. This was the end of my presentation. I hope to see some of you tomorrow during my workshop. And I hope that the value system and the way of visualizing resources has inspired you also to create more circular projects. Thank you very much.